Okay, 21. Simple random sample N is drawn. Sample mean X bar is 18.4. S is 4.5. Construct a 95% confidence interval. So that's X bar plus or minus T star times S over square root of N. So that's 18.4. T star I have to look up. And that's 4.5 over, we said N is 35 square root. So how do you find T? I do want to look that up. So if I look up for 95%, which is 1.96 for the Z, but since the sample size is 35, I have to look up 34. It's called the degrees of freedom on the table. And if I look up 34, I get 2.032. So I'm going to be looking for that number. And then if you do the actual calculation on your calculator, it's going to be 16.9 to 19.9, which is actually 20.0 if you round it off. Okay. So there it is. It doesn't have to interpret it because there's no context, but it's on the last video, number 19, if you need help with that. So there's A. B, construct a 95% confidence interval for mu if the sample size is 50. So that just changes that to 50. And it's also going to change that. And if I look that up on my table, it's going to change it. There is no 49 on my table, so I go up on the table to the next one, which is 2.021. So that's what I get for here. So it'd be 18.4 plus or minus 2.021 times 45 over the square root of 50. And if I do that, I get 17.1, 19.7. And that interval got smaller, didn't it? Okay. C. 99% confidence interval for N is 35. Oops. 99, so that'd be same, 18.4 plus or minus. I'm going to look over here at the 99% for 34 on my table. So make sure you can do this. 2.728. I will provide the table for you on the test. Times standard deviation over the square root of, we're on 35. That's 4.5. And if you do that, you get 16.3, 20.5. And so if I just increase the sample, what happens to my interval? Well, same sample size. This was 95%. This is 99%. My interval just got a little bit bigger. And D, if the sample size is 15, what must be satisfied? So if N equals 15, which is less than 30, the population must be approximately normal. Okay, there's 21 for you. Let's look at 23 on this one. 23 hours worked. N is 1100. We want to make a 95% confidence interval for the mean number of hours worked. And so we found a 95% confidence interval to be 42.7 and the upper 44.5. Which of the following is a reasonable interpretation of the result? Looks like I got 4 of them. And again, that's the answer because you can see that we're 95% confident the mean number of hours worked is between here and here. That's perfect. Textbook, no pun intended since there's a textbook. A, 95% probability. Why is this wrong? There's a 95% chance that the number of hours worked was in there. No, there's no chance that it's in there because it's either in there or it's not. So that doesn't make sense. Okay. 95% of adult Americans worked? No, because this interval is about the population proportion or population average of all Americans. and I'm 95% confident that the mean number of hours worked by adults in Idaho the previous week was between here and here. Well, what's different between B and D? This is just adults in Idaho. Well, what's my sample for? We did a survey of 1,100 adult Americans, not just those in Idaho. If my sample were just Idahoans, then you could generalize it to Idaho people, but my sample was all Americans, just period. So that means I generalize it to all America, not just Idaho people. All right, there you go on that guy. Let's leave it there and do the next two on the next video.